Well, thanks again, Tom, for joining us.
No, you're very
again.
welcome.
I appreciate it very much. At the end of our last time together, we were talking a bit about your efforts working with Charles Simonyi and Butler Lamson at the beginning of the Bravo text editor word processor project. And we also discussed that this was in part framed within the context of Charles's PhD thesis dissertation work for Stanford, and that the initial work on the editor took place, at least according to Charles Simonyi's thesis, between July and September of 1974, about 13 weeks, I think.
Okay.
There was some, I was just wondering about, two things I wanted to ask. One was about the sort of collaboration between the three of you or anyone else involved in kind of building Bravo, and also to talk also about the piece table as a kind of the fundamental data structure for Bravo, and it's your thoughts about the importance or the implications of that data structure.
Okay. Well, in terms of the collaboration, my collaboration with Charles was on a daily basis, and the whole philosophy that he brought to programming was that there was a team, in this case a pair of people. He was the meta programmer, and he was writing specifications for me in essentially English, somewhere between English and pseudocode, and handing that off to me to as the technician to implement in BCPL, which was the language that we were working in. Now, I think he and Butler also probably had a fairly intimate relationship, professionally intimate relationship on, I don't know whether it was a daily basis or close to it. My interactions with Butler were more casual, I would say, in those early days, because Charles was the interface between the two of us, but he was always open to me walking into his office and asking questions or getting guidance. But I don't remember it being kind of a daily kind of thing.
Okay. And the piece table data structure that you were busily implementing for Bravo, could you talk about it?
Well, I think the piece table, I know Charles, I've heard Charles speak, and I know he considers it, one of his great accomplishments, and I think it is his and Butler's. But I see it more as an example of the kind of design that really permeated the Alto, and I think the philosophy largely came from Butler and maybe Chuck Thacker as well, but Alan Kay as well, I think. This notion that they were going to build something that could just barely do what it was they wanted to do, because they wanted it to be as inexpensive as it could. They wanted it to be as much in software as opposed to hardware as it could. So the hardware was very simple for the Alto. It had a lot of memory for 1974, but it didn't have a lot of memory for the kinds of tasks that they wanted to accomplish. And so there are a number of design decisions throughout the design of the Alto and the software that ran on the Alto that reflect this sort of minimalist philosophy. And I think piece tables are an example of that, because the idea was that we wanted to have documents that were larger than would fit in memory. And if that was going to be the case, then we had to have some kind of data structure which would let us keep the most of the document on the disk and only bring into memory the portion that was necessary for whatever was going on at that particular moment. And the piece tables were the vehicle for doing that. Remember, because it was so simple, there was no virtual memory. If I remember correctly, we barely had parity on the memory in the early days. We'd have to look that up, but everything was bare bones on the Alto. Another example of this, which I think we talked about last time, which I was very impressed with as I was reviewing what we were doing for the demo last year, was this feature that Chuck and Butler built in, I assume it was Chuck and Butler, built into the hardware, where you didn't actually have to allocate a full bitmap for the bitmap display if you didn't want to.
Oh, right.
Remember that Smalltalk did, and that was half of the main memory, essentially, was the bitmap. But we did not in Bravo. You could allocate blocks of memory that just represented like each line. It represented horizontal swaths of the display, and the microcode would pick up those blocks and turn them into the output for the scanned CRT, and that allowed us to have much less than half of the memory devoted to the bitmap for the display. And there's really numerous other examples of things like that, of how we made design decisions, or they made design decisions that were direct consequences of this minimalist philosophy. And the piece tables, I think, is the one that Charles is most proud of, and rightfully so. I implemented all of my text editors and word processors with piece tables right up through Apple and Adobe and elsewhere.
Well, you're prefiguring a whole set of questions about the piece tables in your subsequent work.
Yeah, sure.
I'm so glad to hear that, and glad that we can get to it. Could you? I think I have. Well, I would love if you could take a stab at explaining for a viewer of this interview, and for me, who doesn't have a tremendous depth of detailed technical knowledge in this area, what the piece table was and how it afforded this kind of minimalistic approach.
Sure. Well, first let's just imagine or take it as a given that all of the characters and the formatting, everything that makes up the document is residing on the disk somewhere.
Right.
We'll take that as a given, and then we talk about how we make sure that happens a little bit later. Well, to begin with, that means that you can describe the document in main memory with a single piece or a single record that says, go to the disk here and read for however many characters there are in the document the information that's stored at that place on the disk. That's the description of the document. That's a piece table with one piece in it.
Right.
But now let's imagine that you remove a paragraph from the middle of the document. Then you need two pieces to describe the document. You say the first piece starts at the beginning of the document on the disk, and it goes up to wherever that missing paragraph started. And then there's a gap, which is described by adding a second piece that says the second piece begins on the disk after where that paragraph resides, and then goes to the end of the document. Mm-hmm. And then with each with each edit, you build up these pieces, and eventually there could be many pieces, 1 or 2 for each edit, depending on what kind of edit it is. And so the amount of memory that was required, main memory that was required to describe the document, was a function of the amount of editing you've done, not of the length of the document. And that was the essential idea.
And was, and then it would only be at certain defined intervals that the kind of edits represented in the piece table would be sort of written to the disk and creating a
Resequenced.
And creating kind of a new saved version of the document.
Exactly.
One thing that I haven't been clear about, forgive me, is whether or not the piece tables were implicated in in Bravo, sort of going to the disk and getting information for putting on the display, or was that a separate function? So let's say I'm using Bravo and I want to go down a couple pages. I'm going to edit page 11 and insert something there. Was that separate functionality that was handling?
Think of it in object-oriented terms. The object that was the document was encoded in this piece table. So regardless of whether or not you were displaying a portion of the document on the screen, or searching through the document, or performing an edit, everything went through that piece table data structure.
That was how you went through the piece table to get to the information that was
always.
stored on the disk.
Always.
Interesting. For everything that you were doing.
There was no way to even refer to pieces of the document or resolve references to the document except by going through the piece table.
Okay. So for something like, I want to look at page 11 and do something, it would, the editor would be sort of calling or referring to the piece that contained or pointed to page 11, and then put it
all
on
the references
screen.
started out as a document and essentially character index.
Right.
And then that character index in the document was passed against the piece table or resolved through the piece table to come up with a location on the disk and a character offset from that location on the disk where that document character index could be found.
Okay. So it's, I think I follow. Thank you. So that's fascinating. So it really is suffuses the entirety of the functionality of that.
Yeah, absolutely.
Okay.
Yeah.
Thank you very much for that.
Sure.
Could you talk about the relationship between Bravo and this and I guess it's a language, press for printing? Was press something that Bravo could kind of call upon externally, or was that
we generated press from Bravo when we printed to the first of the printers that Ron Ryder designed. Well, no, let's see if you first of all, you should check my facts on this, but I think the first printer that was designed was Ears, if I'm not mistaken,
that's
and
correct.
I think that was before Press. But Press was a printing language, and in general, once these printers came online in the research center, we developed code in our print command that would generate whatever print language was necessary. First ears and then press, I guess. We'd have to check on that.
But it would be.
But that's a totally different representation of the document
Right.
than what we worked with on an interactive basis.
But it would have been the print functionality within Bravo.
That's right.
To create the press
That's right.
file.
It was all. I think we discussed this last time, but remember that Bravo, it didn't quite run on bare hardware, but almost. So there was no print libraries or anything like that.
Right.
We started with our representation, and we wrote the code that generated the print representation. We took some code from Bob Metcalf to actually send it out over the Ethernet, but that wasn't a library. That was, I mean, it was built. Then it was built into and part of Bravo. It was not part of any operating system. So yeah, when we brought up the first printer, we were also debugging the first Ethernet code. It was, well, I mean, they had used it for a few other things, but we were still shaking down that code too.
We did also talk a little bit last time, but I'd love to hear you expand a little bit more about the fact that initially, or the most avid use of Bravo once it really kind of got going was as an editor to write programs, to write other software.
Actually, I don't think that's quite accurate in terms of the number of users. There were probably more users using it as it was intended as a piece of office software, because remember the number of developers was, well, there was our team, and then I guess there were quite a few developers, and I would have to count noses. The Smalltalk team wouldn't be using Bravo to write their code. I don't think they'd be doing it in Smalltalk. I guess the rest of CSL probably used Bravo. I would think. They could still use a line editor if they wanted, but they probably used Bravo. Certainly we used Bravo. But everybody that had an Alto, from staff people, management people, administrative people, and researchers and technicians, everybody used Bravo for writing memos and other office uses. Right. So it'd be, I would, as I just said, we'd have to count noses, but
okay, yeah,
it was
so it
being used extensively in both.
I see.
Both ways, I think. And if somebody came back to me and said, no, there weren't nearly as many people writing code with Bravo as we're hypothesizing here, I wouldn't necessarily disagree.
Okay, and I suppose by this point in time in the sort of story of text editors, it was known that the features that would make an editor good for writing code would also be helpful for writing other kind of literary documents, memos, reports.
Well, I think it's the other way around. I think Bravo was really designed to be a office document creation tool.
Yeah.
And there was this period when it was also better than anything else, or as good as anything else, for developing code. If we think forward, not very many years, probably 76 or 77, when Mesa comes on the scene, Mesa will have its own editor somewhere in that time frame, 77, 78, right. I don't know when. Right. And so clearly program editors develop a life and a history of their own fairly quickly. Right. But remember, in 1974, the first Alto came off the assembly line in 73, I think. When I got there in 74, there were only about 6 or 7 of them. Right. and so we're building from scratch. And so in terms of programming, other than the Bravo team itself, my guess would be that the heyday for using Bravo as a program editor was probably, I don't know, 75 to 77. I'm just guessing. I don't know.
Okay, that makes sense. And also your comment about the Mesa environment and its editor resonates with a question that I had written down here about the inner Lisp environment.
Ah, yeah.
Which had...
Right, exactly. They had their own editor.
And I had a chance to talk to Jay Struther Moore, who I evidently kind of independently and almost simultaneously with Butler Lampson also conceived of basically the piece table structure as well.
Oh, really?
And he was at the University of Edinburgh making an editor for a time-sharing system, the same space power constraints, and came up with a similar notion. And he was, in fact, at PARC for about a year, and
we implemented his search algorithm in Bravo.
The
Boyer-Moore algorithm, right? Yeah.
Right. Well,
I mean, he invented it, and then we implemented it. Pretty much in real time, I think, if I remember correctly.
Oh yeah, I think it must have been right after he and Boyer conceived it.
Yeah.
It was when he came to PARC. But he was telling me that he was really working with the editor functions for inner Lisp and bringing his kind of the same piece table approach into that world. So it's an interesting case of simultaneity and these contexts mixing. But I wondered if you...
Well, and the people were mixing too. I mean, everybody was on the same hallway, so...
Right. I wondered if you had any recollections about just that, about Moore being at PARC and...
Well, I do because of the search algorithm. I didn't have a lot of interactions with him in other contexts, but I have a vivid recollection of, somebody coming to me, whether it was Jay or Charles or somebody, and saying, "Hey, we got this new search algorithm. And it's better than the." I think we actually implemented Jim Morris's algorithm first, and that's got somebody else, so a few other people's names on it too. I don't remember what. Anyway, I don't remember what the name of that search algorithm is or the names that go along with it. But I think we implemented that one first. But then very quickly after that, Jay arrived and we learned about this algorithm. And somebody said, "This is the best thing since sliced bread. We got to go implement it." We did. And so that was the standard search algorithm in Bravo from then on.
And it's my impression that it's still widely used.
I would imagine. I don't know of any better to this day. It's a sublinear algorithm. You don't get to find those very often.
Well, I was wondering about, I guess, the picture of the overview of your roles at PARC, because I wasn't quite sure when you departed PARC for Apple and just what the sequence of things you were doing at PARC was.
Sure.
Yeah.
So remember, I started as a summer intern, essentially, what we would today call a summer intern. But I had already graduated, so it wasn't like I was going back to school.
Right.
And I was a temporary employee the entire 2 years that I was at PARC proper. And, they just kept paying me my hourly rate, whatever, some ridiculous rate. I think it was started out at $10 an hour or something like that. And then in the grand scheme of how PARC was going to be successful, they started spinning off development organizations. After that was in '76. So the first 2 years, Charles and I and everybody else was in PARC proper. That's basically the organization that was there inside the computer science lab, and we developed Bravo there. I'm pretty sure it was '76. The Systems Development Division was founded. Dave Liddell was the head of that. And a lot of people left PARC at that point to join the Systems Development Division. Bob Metcalf was an executive in that group. Charles went there and took me, as well as the Bravo team was probably 5 or 6 people by then, I don't know. And the entire Bravo team went there. And actually, we didn't go there to work on Bravo. The Systems Development Division was the organization that would ultimately build and ship the Star. Okay. They were going to do all their development in Mesa. They did all their development in Mesa, or at least all the software that shipped on the Star was written in Mesa. Mm-hmm. And our assignment, Charles's group's assignment, was to start developing substantive software solutions, applications in Mesa, in anticipation of the D hardware coming online and all that sort of stuff. And I don't quite remember whether we were supposed to be re-implementing Bravo in Mesa at that point, or whether there was some other assignment we had. But the Mesa tools were so primitive, or they weren't up to the task in whenever it was, mid-1976. And so we basically brought the development environment to its knees in a fairly short period of time. And you'd have to check with like David or Bob or Charles to get the real story about how this pivot happened. But we basically had time on our hands, and we went off and started just working on other projects. And it seemed like almost everybody in Charles's group had a project of their own for a while. And my project, which I came up with, was called, I named it DeSoto after the car. And it was an early incremental compilation environment, maybe, or it had the following features that you would now find in integrated development environments. And this was all in Mesa. So it's not like we went back to developing Bravo in BCPL. Instead of developing, this is my recollection, instead of developing, Office applications in Mesa, we went off and started developing tools for the Mesa environment because the tools were so lackluster at that point. And so what my tool did was the compiler was really, really slow, and there wasn't really much of a linker. That's my recollection. In any case, the process of recompiling an application was excruciatingly slow. And so I came up with this notion, which now people would call incremental compilation, I think, which is sort of like a step beyond make. So make keeps track of the static dependencies between different files or modules in a larger program, and schedules recompilations of things that, if you change one source file, it'll automatically recompile the things that depend on that source file. So we went one step further, or I went one step further, and I would actually go inside the compiled object file and find out what changed from one compilation to the next. And if there were no externally visible changes, if you just changed the inside, the stuff that's only visible inside the source file, I wouldn't schedule any recompilations. And then I would go even further, and at a symbol, basically at a symbol by symbol level, like a procedure or method call level, or a instance variable or global variable level, I would look to see whether any changes have been made to that particular procedure or method. I don't remember what they're called in Mesa. And I would only schedule a recompilation for a dependent file, Mesa file, if it actually used that one of those methods that changed. And so it made rebuilding of the system go exponentially faster. And then after that, I also added, there were 3 levels, I think. There was sort of the basic make level, and then this fine-grained recompilation level. And then I also did a very primitive source code control system where you could check changes into an IFS server and thereby share them. And so I probably spent a year on that. And Greg Shaw, I think, developed a debugger. But we weren't part of the tools team. We were part of Charles's team. So even though the tools, the folks that were really responsible for Mesa tools, I think were interested in what we were doing and learned from it, I'm not sure anything ever became of any of those tools that we built.
Was Chuck Geschke in charge still of Mesa? Because I thought he had been
Not
initially.
in SDD. I don't think he ever left PARC.
Got it.
Because when he left to found Adobe, he was still at PARC.
Yes.
So.
Okay. So no, this would be getting again to like the production version of Mesa.
That's right. Yeah.
Yeah. Okay. So
right.
different group.
Right. And Chuck, I think of Chuck as being primarily responsible for the language.
I think that's right.
So this is sort of his baby had grown up and gone off into the world.
Was there, I'm forgive me for not knowing this, there was a physical move too out of the
That's
building where you had been. Where was the systems development group located?
Where were we? We were across the street, I think.
Okay.
I have a definite picture of what the office looked like, but I can't remember where it was. I think
Very
it was just
nearby.
across the street. Yeah.
Yeah.
So that was probably. So if the first 2 years were at PARC, then we probably spent another year in SDD, maybe more. I don't know. I was there almost 5 years. And then there was one more move. There was yet another spin-off from PARC called the Advanced Systems Division, ASD.
Okay, I've heard of that.
And that was founded, or the founding head of that was Jerry Elkine, who used to be the head of CSL. And he had a different mission. So let's just say for the sake of argument, we spent about a year. SDD had been in place for about a year, and or however long it took, it became obvious it's going to take a whole lot longer to build the star and ship it than people thought, thought initially. And so there was a desire on some people's part, I assume it was driven by Jerry, to get Altos out into the world in sort of like this expanded beta test almost. And that was ASD's charter, was to go out and do prototype deliveries of Altos with Bravo and the mail program,
Laurel,
and a few other things, and put them in real offices and get some real feedback. And so we moved to that. Charles's group moved to ASD at that point, and then we went back to working on Bravo again, and BravoX was developed in ASD, and we delivered to places like the White House, and I don't remember where else, but I distinctly remember our White House installation. And that's where I finished my career at Xerox, is I left in late 78, early 79.
Okay. And
I think that's right.
and while you were doing this work, you were also doing a master's at Stanford?
Yeah, that was 77 and 78, I think. Yeah.
Okay.
Yeah.
And the BravoX was, if I understand correctly, developing Bravo so that it could incorporate some features and functions that had been pioneered or implemented in Gypsy. Is that correct, or were there?
Well, we definitely wanted to get a better user interface. So remember, Bravo was not a modeless user interface. It was a very mode-full user interface, right. And I think everybody knew early on that that was not the right choice, but it wasn't what we were focused on in user interfaces was not what we were focused on in 74, even 75. So it was probably 78 by the time we got around to having the resources and the desire and we're going to put this in, customers' hands.
Right.
So a high priority was developing a modeless interface for sure. Yeah. And also just, since we were now going to have real life customers, they had enhancement requests, and so we were putting more features in. And I don't really remember too much about what the exact features were, but the user interface was a big part of it.
Yeah, and I suppose this would be when the first external users come into the picture, right, in a way. So it makes you look at I would imagine it makes you look at the program with fresh eyes about how these people would approach it.
Well, yeah, I mean, when your customers are your colleagues and fellow developers and researchers, they have one set of expectations. When they're somebody in the White House, there's a different set of expectations about what your software does and doesn't do.
I was curious with what engagement, if any, you had with the microcomputing scene in this later portion of your time.
I wasn't really plugged into it at all.
Okay.
You mean like the computer clubs and things like that?
Yeah, or people making, home microcomputers, anything like that.
No, it wasn't.
Okay.
Wasn't anything I was involved in.
I think that would have put you in the mainstream of people at PARC, not having.
Yeah, right.
The reason for my question is just about your departure to Apple.
Well, first of all, I didn't go directly to Apple.
That's what I was curious about.
So I left, as I said, in late 78 or early 79. And when I decided to leave, I sent my resume to a few companies in the Valley. I mean, it wasn't like anything like it is today in terms of being obvious how you go about, find another job in high tech in Silicon Valley. Now you just go out, stay on a corner and somebody picks you up. But I did send my resume to a few different companies. Apple was one of them in that when I was leaving Xerox. But another one was Zilog.
Yeah, sure.
And I sent my resume to Zilog. I don't know where else I might have sent my resume. And to show you how naive I was at the time, I wanted to leave Xerox, or at least my recollection of why I wanted to leave Xerox was because, I wanted to get my work product into products and into people's hands, and also I wanted to work for a smaller company. Xerox was a big company and a big corporation, and I didn't like the bureaucracy. There were things about the bureaucracy I didn't like, and so I wanted to work for a smaller company. So to show you how naive I was, I didn't realize until I got to Zilog that it was owned by Mobile Corporation. It was a fully owned subsidiary of Mobile. So I thought I was going to like this little kind of startup. I'm not sure we even called them startups then, but it was an established company for sure. But I thought it was a small company. And it had aspects of a small company, but it was in fact owned by the largest corporation in the world at the time, I think, Mobile. So I went there and I joined a group whose mission was to develop software and hardware based on the new Z8000 processor that was just coming off the chip lines. And they had aspirations to build office equipment kind of hardware and software. But it didn't take me long to figure out that I was in the wrong place. First of all, this group was run by Charlie Bass and Ralph Ungerman. By the time I had gotten there, Ralph Ungerman had already left, and Charlie Bass left before I did, and I was only there for 10 months, and they founded Ungerman Bass.
Right.
Zilog just didn't have the commitment or the resources to do what I thought we were going to do, even though the people that I was working with, thought that we were going to do that. And I met some of the some people who went off to really do wonderful things in the industry, like Judy Estrin and Dave Folger and people like that. So it was a great experience, but I was there from like January to October of 1979, because it was obvious that my job was to build a word processor, but I was building a word processor on hardware development systems.
Right.
So it just didn't make any sense, and there was no sign that there was actually going to be, some kind of computer that made sense for my software. So in parallel with me saying, oh, geez, I wonder what the heck I'm doing here, I'm sitting at home one night, and I don't know whether I got a phone call or a letter, but somebody from Apple, this is like 8 months after I had sent in my resume, called me up and said, or wrote me a letter and said, hey, we just saw your resume, and we think you'd be great for Apple, and we'd like to have you in as soon as possible. I think it was a phone call. I'm not sure, because I said, well, that's kind of old news. I left Xerox back at the end of last year, and now I'm at Zilog. But they persisted, and also the reason I sent my resume to Apple to begin with is because I had a friend who I was an undergraduate at Stanford with, who graduated, went to business school, and then went to work for Apple in about 77 or 78 probably. Probably 78 would be my guess, I don't know. And so he was also trying to find me a place at Apple. And so finally, that's kind of the stars aligned, and somebody introduced me to the guy who was the engineering manager for the Lisa group. I'm blanking on his name right now. That's horrible. Anyway, it'll come to me. And I interviewed with the Lisa group, which was smallish, but not small. There was probably half a dozen people at least in that group at the time. And they wanted a word processor too, and they claimed they were going to build, a real computer for people to use as opposed to a development system for people to design hardware for the Z8000.
Right.
So it all sounded much better to me. And I had these friends there that kept saying, or a friend who kept saying, this is a great place and you should come to. And it was a real life startup.
Not owned
It was
by an
not owned
oil
by
giant.
mobile.
Yeah.
So I quickly pivoted. I don't really talk about my Zilog years other than the people I met. In fact, that's where I met Bernard Poutot, who's so important to the History Museum.
Absolutely.
And we remain friends to this day.
I did an oral history interview with Bill Carrico, who told me all about that Zilog context, because he was over
Bill was there as well.
in that mix.
Right,
and also in that interview,
Manny Fernandez. Do you remember Manny Fernandez? He went off and formed Gavilan.
Yeah. Sure, yeah. I think that was how Bill Carrico got to Zilog.
Is it? I don't know.
He had worked with
Manny?
for Manny previously at Fairchild, if I'm not scrambling my story.
That could be.
But one thing that Bill Carrico did talk to us about in our interview with him was that there were close social ties between people in the Zilog scene and people from the PARC scene. And that I wondered if that had at all been a factor for you knowing about Zilog or thinking of going over there.
I don't think so.
Okay.
And you know, I may have been part of that catalyst for all I know.
Oh, yeah, true.
I was certainly part of the catalyst between Apple and Xerox, so I may have been part of the catalyst. I don't know.
And may I ask about your friend who had been at Apple?
Mm-hmm.
Who?
His name is George Johnson. He was a marketer.
Okay.
And he was at Apple and in the early days, and he moved up to the San Juan Islands many, many years ago and still lives there and very happy. He's done a variety of things since then.
Okay. Well, and so this would be sort of in the second half of 1979-ish that you joined
October of 79 is when I joined Apple.
Okay.
I know, just because your hire dates at small companies make a lot of difference financially. So I remember my hire date at Apple and at Adobe, or at least I remember the months.
Yes. Well, great. And had Larry Tesler gone to Apple at that point?
No, Larry came afterwards.
After, that's what I thought.
I was the first
That's what
Xerox person to show up at Apple, to the best of my knowledge.
Yeah, that's what that's what it looked like to me. So I'm
Yeah.
glad to hear,
Yeah.
glad to hear that confirmed.
And it was before the demo, before Steve got his demo, so it was not like...
It was 2 months earlier.
Yeah, right.
Yeah.
So I think Larry came shortly after the demo.
That's
probably
right.
He gave the demo, so I assume that Steve, recruited him because of that. But my arrival was kind of serendipitous.
It wasn't part of a movement toward.
It wasn't like they knew about
Right.
Xerox and they were trying to recruit people out of Xerox. I had left Xerox, months before, and so it was really kind of coincidental.
That's fascinating. Well, how did Charles Simonier and the other people you were working with at Xerox, how did they react to your departure? Could they understand? It sounds like you had a common, maybe a shared concern with some of them that it was going to take longer than people would have wished for things to really get out.
Well, lots of people left Xerox for those reasons, and I think that was part of the reason I left Xerox. But I think part of it, it's hard to know it's so far in the past. But I think part of it was just it was time for me as an individual to go. Remember, I started out as a snot-nosed kid. I was working as one of Charles's technicians. I do remember that, I kind of thought I was underpaid, and I felt like I was in this big bureaucracy, and so my leaving, and oh, by the way, and as I thought about what I wanted to do, I wanted my stuff. I believed what now is this sort of in historical hindsight is the motivation for many people having left PARC, but I'm not sure that that was just one factor for me.
Right.
So I was just this, 1978. I was this 26-year-old guy. Just, I'd been in my first job for 5 years, which now is an eternity. And my career wasn't advancing quite as fast, and I was in this company that I thought, was kind of a bureaucracy. Charles was telling me, no, just stay here. I'm going to take care of you. Jerry Elkine was telling me, no, I know you think we're a big bureaucracy, but I can fix this. In fact, as I was out the door, they were actively trying to fix it, so I would stay. But, my motivation for leaving was personal rather than, this grand professional perspective that,
right.
By the time Chuck and John left to form Adobe, or by the time Bob Metcalf left to found 3Com, or by the time Charles left to go to early Microsoft, I think their motivations might have been more clear and more pure in this historical storyline, but mine was really just more mundane.
I imagine it's a mix for
It is a mix.
everyone.
It is a mix, for sure.
It has to be a mix for
Yeah, right.
everyone. Could you describe the Lisa project as you found it then?
Yeah.
What was it? You kind of walk in the door. What did it look like? Where did you sit? What was it like?
Well, the most important thing for you to realize is that the day I arrived, I thought I had made another terrible mistake. So, like the week before I was scheduled to arrive on Monday, probably like on Friday or something, I called up Ken Rothmuller. That's the guy's name who ran the project. I called up Ken and I said, look, I'm coming on Monday. Do you have anything I can read in advance to sort of be prepared and hit the ground running? And he said, sure, here, I'll give you the project notebook. You can take it home for the weekend and read it. And it literally was a notebook, and it had mostly hardware stuff in it. And I was reading through this this notebook, and it was describing the original Lisa hardware. I don't know whether you have this in any of your interviews or historical archives anywhere, but the original Lisa hardware was something that was designed by Wozniak. It was a 8-bit bit slice processor that was going to run what you would think of as bytecodes today. It probably was bytecodes then. And I could tell just by looking at the specification it was dog slow, and it was going to be a horrible, horrible problem that we weren't going to have the oomph to do what we wanted. But it was a classic Woz design, right? It was, talk about minimalist. It was like 6 chips
Half
or
a
8
chip.
chips
Yeah.
or something like that. Except he had passed that minimalist design off to some other hardware designers who now had it expanded out to a board or two. And anyway, so I was kind of depressed going in on Monday, and I thought I was going to have a conversation about how maybe I made a mistake coming to Apple. But before I could say anything, Ken grabbed me and everybody else in the office. This was a suite behind the Good Earth restaurant in Cupertino. It wasn't even on Banley Drive. It was a tiny little suite. with a couple of cubicles. He pulled us all into his office/conference room, and he said, "We're throwing out the old hardware design." I, Ken, and somebody else, I don't remember who, maybe Rich Page, just flew down to Austin, Texas on Friday. We went to Motorola and we saw this new chip called the 68,000. It's not even off the assembly line yet, but it's going to be here whenever it's going to be here. And it's going to be like so much better than this hardware design that we have here. We're going to throw out this hardware design. We're going to start over, design something based on the 68,000. I went, whew. Oh God, I'm so happy. I didn't even know the details of the 68,000, but at least it was a 16-bit processor, not a 8-bit processor, and it was an integrated CPU, not this. I shouldn't complain about bit slice processors. That's what the Alto was too. So the project actually was about a year old then, I think, at least, but it restarted on the day I arrived. Coincidentally, it didn't have anything to do with my arriving. It had to do with the fact that they had gone to Austin on Friday. And so we started over. And what else can I tell you about the early days? I told you, physically, we were in this tiny little suite. I mean, Apple itself was tiny at that point. There was only a few hundred people there. But there were bigger buildings on Bandley Drive, and we were in literally just a tiny little suite. The overall design of the Lisa was, I have to say, also pretty uninspiring in that first iteration. Ken and a guy by the name of John Selden and probably a bunch of other people whose names I don't remember were from HP, along with I can't remember the engineering VP for all of Apple at that time was a guy from HP who had come from HP. It's Tom somebody, I can't remember his last name. Anyway, I don't know whether you have any HP 100s in the computer museum or not, but they were inspired by I think it was called the HP 100. Anyway, it was a computer with a keyboard and soft keys along the top of the keyboard. Oh. And then it had a CRT, but not a bitmap CRT, I don't think. And then the keys appeared at the bottom row of the CRT, whatever the label was for the button. Yeah. No mouse, no bitmap display. I think, if I remember correctly, the display was going to be yellow because the best ergonomicists of the day were Swedish. At least this is my recollection. And they had determined that the most ergonomically pleasing or satisfactory color for a display was yellow because it was easy on the eyes. So I think we were going to have a yellow display, no mouse, no bitmap, no graphical user interface, soft keys. And so that was sort of the starting point when I arrived. No, I don't think I honestly marched right into Steve Jobs' office and said we can do better than that. But the marketing manager, or whatever his title was, director for Lisa at that time was Trip Hawkins, who went off to found Electronic Arts and many other things. And so I was interacting with him almost immediately, and another guy by the name of Glenn Edens. I don't know whether you know Glenn.
I've heard the name.
He went many places, but he was at Sun for many years. And so in addition to talking to my engineering colleagues, I was also talking to them, and they were, I'm sure, picking my brain about Xerox and PARC and things like that. And so I started describing the mouse and the bitmap display, and it wasn't very long before Steve got involved in those conversations, and it wasn't very long after that they somehow wormed their way into PARC for their famous demo. Right. And it wasn't long after that that the whole project got reorganized again around building what we now know of as the Lisa.
Okay. And during this time when you're having these discussions in the, earliest months of your time at Apple, what was your kind of remit? What was it that you were supposed to be doing?
I was supposed to be building a word processor, just like I
Okay.
did at every job for many, many, many years, many iterations. I didn't start out building word processors at Adobe when we get to that. In fact, I never built a word processor per se, but I built the guts of word processors into Illustrator and other things.
Well, okay, so it was very clear.
It was very clear.
Were there a set of other people in the Lisa group who were going to make other application programs?
Yeah. Ultimately we had 5 applications, right? I don't remember whether we had team leads for all 5 of those at the time I arrived or not, but probably not. I don't remember which ones were there and which ones weren't. Okay. Bill Atkinson was there, but Bill, rather than working on an individual application, more worked on what we would think of as the application layer. Right. Who else was there at the time? Well, Jeff Raskin was not part of the Lisa team, but he was there and he was having an influence because he was imagining his vision for the Macintosh at the same time we were building the Lisa. I'd have to scrub my memory for who else was there.
Okay. Well,
Rich Page was definitely there. He was the hardware guy, or a hardware guy. And then there were some people who were there to develop systems, so to develop an operating system. Because this, unlike the Alto, it was the expectation from the start was that it was going to have a real operating system running on it.
Mm-hmm. Well, let's see. So I suppose it was by early 1980 that the second reorientation of the Lisa towards the kind of PARC idiom, if we could say, that gets going. Could you describe then, the unfolding of LisaWrite and building that?
Well, I'm not sure I have any particularly memorable stories off the top of my head, but it went on for a couple of years after that, right? We didn't ship until 1983, so there was lots of iterations and team growth and drama. Steve was very involved in the early days, but then he became involved with the Macintosh, and he wasn't involved at all. Wayne Rosing came in after Ken Rothmuller to lead the team, hardware and software. We had the 5 applications. We had the application layer that Larry and Bill were so influential and important to. The operating system, the Lisa operating system, was actually pretty heavyweight for what we were trying to do, and in those days it would be more like a Mac OS 10 or a OS 2 kind of operating system, as opposed to the Mac operating system, which was more like a DOSy or a single user, lightweight, very little protection kind of operating system. So that was an extensive effort. It was a controversial effort because a lot of people, maybe even me included, I don't remember, thought it was kind of overbuilt to the task. And even though we had a megabyte at that point, I think the original Lisa was a megabyte. of memory. We were using it up at a furious rate, and so those of us that came from a more minimalist background would have preferred a more lightweight operating system, I think. But be that as it may. And so we just plugged away. I mean, we had lots of problems to solve that are documented by history. There was the whole Twiggy thing. It needed a floppy disk, and for years it seems like it was going to be this floppy disk that was going to be designed at Apple called Twiggy, which nobody could ever get to work. And eventually we switched over to a Sony smaller disk.
Right.
So there's lots of drama around that. Delays, I'm sure we weren't supposed to ship in 1983. We were probably supposed to ship in 1981 or 82. I don't know. And at some point, the Macintosh team spun off, and there was more drama there. I don't know. You have to ask me something more specific.
Okay. Yeah. Well, maybe we could just have you speak to. I mean, you said that you used piece tables in LisaWrite.
Mm-hmm.
Could you talk about just your comparison between BravoX, and LisaWrite? How your earlier experience shaped.
Well, my early experience shaped not just LisaWrite, but other things as well. Probably the first thing I did, Charles doesn't mention this, I think, as one of our more memorable accomplishments, but I actually think right up there with piece tables was the memory manager that we built for Bravo, which also was, I think, designed by Butler, I'm not sure. And it was a relocating memory manager. So the standard memory manager, even to this day, Malloc, is a fixed memory manager in the sense that if you call Malloc and ask for a block of memory of 100 bytes, you get a pointer to that, and that piece of memory, that object, or whatever you want to call it, that record, is always at that address in memory.
Okay.
Again, we had so little memory, we didn't want to, and that causes fragmentation over time as you allocate and free things. And back at Xerox, we were so concerned, or Charles and Butler were so concerned about not wasting any memory, they designed this relocating memory manager. We call it the heap, but there's so many things called the heap.
That's what I was just going to wonder, because I've seen
so many things
throughout the Bravo source code.
Right. There's so many heaps today which are not relocating memory managers that the term has kind of been co-opted. But our heap was this relocating memory manager. And so instead of pointers, we had pointers to pointers as the reference to these records or objects or whatever you wanted to call them. And so there was only ever one pointer to the actual object, and that was inside the implementation of the memory manager. Everybody else used these pointers to pointers. And so that meant that you could actually compact the heap, move all of the objects so that they were contiguous, and then just update this one pointer,
Right.
and nobody would be the wiser, basically, on the other side of the interface.
This is a form of indirect addressing,
Exactly.
correct?
Absolutely.
Okay, so
Yeah.
I get it. You point into the memory manager, and it's figuring out all these smart things to do to keep things together and avoid fragmentation,
Exactly.
and
Right.
and really be smart about where you're putting things,
Right.
and the program doesn't have to worry about
Well, the
it.
program has a pointer to that pointer.
Right.
And so it's not as seamless as modern day virtual memory because it's all in software. Clearly, when that application software wants to reference the stuff in the object, it has to go through that pointer,
Yes.
and maybe it ends up putting that pointer into a temporary location. So you have to be careful about not having those dangling pointers.
I see.
So you get yourself into trouble with this, but in the absence of hardware support like modern day virtual memory, it's a very elegant solution. So the reason I bring this up is because the very first thing I did, pretty much at every job I've ever been at, I think, is, well, for some number of years, was I implemented a heap. For whatever application I was building, I developed a heap, an implementation of this heap memory manager. So I did that for LisaWrite, but actually all the applications used that code. So that became part of the application environment that we associate with Bill and probably Andy Hertzfeld on the Mac side and other people. In fact, I saw in one of the many books written about the Macintosh that Andy Hertzfeld gave me credit for that because he said that was the only, I think he said that was the only piece of software that ever came from the Lisa, actually came from the Lisa and was adopted by the Macintosh team. It's a very simple piece of software, but nevertheless. So I also developed a number of things that went into the sort of core application environment.
Right.
But getting back to LisaWrite, LisaWrite, I think, was a fairly natural evolution from Bravo to BravoX to LisaWrite. So it had a mode-less user interface like BravoX, had piece tables, and it had the heap storage inside of it. It had most of the features. It probably had a Boyer-Moore search algorithm in it. It had a user interface that was consistent with and inspired by the work that Larry was doing for the overall look and feel of the Lisa. It had one user interface element that I think I was the first one to actually design and develop, which is the find and change dialog for LisaWrite. I wanted to take the modeless notion as far as I could, and so this is not the same user interface that's used in every find dialog that you see, but it's used in many where you have a find and a change and a change all, and when you hit change, it goes and it searches to the, or change and, you have find, change and find, and change all. And that was completely modeless, as opposed to what you did before where you might say find and then you would say replace or something like that. And so that completely modeless interface was one that I developed, and I think it was LisaWrite was the first place that appeared.
And that happened in a dialogue window that opened up.
Right, but it was a modeless dialogue.
Right.
I mean, when you create a dialogue, even to this day, you get to choose whether it's modeful or modeless. Most find and change dialogues were modeful in that you would put everything in and then maybe you would say change all and it'd go off and do everything. This one, because we added those extra buttons, you could change one and then just be back in your document and continue, or you could change and find. But in all circumstances, the dialog box was modeless, and so you could go back and forth and edit in one or the other.
I see.
What were the other interesting features of LisaWrite? It was kind of just like Bravo, just like Word was kind of just like Bravo.
Yeah. Well,
I mean, and the thing about word processors is there's 1,000 features, but which are the ones that stand out? I don't know.
And was it the case that when I talked to Charles Simoni about, like the very first Microsoft Word versions of it, it was, his description was kind of like by employing the fundamental structure of the piece table, kind of latent in there was the ability to, once the kind of host system for Word became more capable, you could add more things in, more features to this, but it was a similar sort of task at the beginning of trying to shoehorn kind of a lot of functionality into an underpowered system. Was it the same for you with LisaWrite? Was it the same sort of shoehorning problem?
I think the more accurate way for me to put it was that because of my history, my knee-jerk reaction was just to build word processors that way. In fact, to this day, my knee-jerk reaction would be to build word processors that way, because even if you have lots of memory, it's an elegant solution, and we didn't think of the Lisa as being that small. A megabyte was pretty hefty. It was bigger than it was more than the amount of storage available, for instance, to an early Windows application on a 640K PC.
Right.
So it was on the one hand, it's kind of a knee-jerk reaction. The other data point is that it was abandoned by the Macintosh team, which had an even smaller computer, but they were not steeped in this philosophy, and they were content in the early days of the Macintosh to have very small documents. So they were also content. Who was it? Was it Andy who wrote MacWrite?
I don't know the answer to that, and I should.
I should know the answer to that too. I did. Whoever did MacWrite simply chose to have their document in main memory. And so even a 128K Mac, which was, I think, how big the first Mac was, you could do a couple-page document and keep it all in memory, and they were happy to do that.
That's interesting.
And in fact, I think they probably stuck with it for a long time because Moore's Law let them get bigger and bigger documents without, using this piece table kind of abstraction.
And this is in some ways just to clarify for somebody who may be listening or reading to this or watching this. The idea there is, one way to handle a text editor or word processor is just to, load all of the characters, into the memory, main memory of the computer.
Take everything in the file and read it into main memory. And
actively edit that, and then at the end, write it back to the storage. Okay.
But hopefully our viewers will see some of the inelegance of that, even if you're not short on memory, because let's say that you want to insert a character at the beginning of your document. You have to, even though it's in main memory, you got to take every character in the document and make space for that new character. Whereas in the piece table case, you just have to make space in the piece table. So instead of inserting one character be the time to insert one character being a function of the length of the document, which it is if you keep everything in main memory, it's a function of the number of edits.
Right. Otherwise, if you follow this approach as with the MacWrite, of having the entire document in the memory, each edit you're essentially having to recompute the whole. You're having to do a transform on all the characters.
You're having to move the characters around.
Yeah.
And if your document is only 2 pages long, who cares? And if you only have 128K of memory, your document's not going to be very big.
Right.
So it was a good design decision for them. I'm not saying they did the wrong thing.
Right.
But it's not the design decision I made, and I think the reason I made the decision I made was more because of the the professional or intellectual culture that I was steeped in than a detailed comparison of the pluses and minuses of those two approaches. It's
Right.
just like if you learn how to write with your right hand, then you don't get up every morning and say, well, am I going to write with my right hand or my left hand today?
Right. It becomes a sort of a design style.
Yeah, exactly.
Yeah.
Mm-hmm.
Two questions. One is about, what was for many people, working with and collaborating with Steve Jobs was very memorable.
Mm-hmm.
Was that the case for you?
Of course. How could it not be?
Could you care to elaborate on that? I mean, what it was, what was it like in this period, 80 through 83?
Well, I don't think I have anything to add to the mythology of Steve Jobs. He was incredibly charismatic and passionate, and he was the driving force that transformed the Lisa and then the Macintosh. Well, first the Lisa from this HP 100 style of computer to what we know of as the Macintosh today. We were both young. We were both in our 20s. We had a lot of fun together. But he was also, the person that we read about. He was difficult, and there's a word that we didn't use back then, but I think when you characterize Steve's weaknesses might be pretty accurate. He was kind of transactional. He could bring all of his charm and charisma to bear on you when he wanted something from you. But if he didn't want something from you, you kind of quickly faded into irrelevance.
Would you characterize sometimes some of his, perhaps using whatever the inverse of charm is, but use sort of a negative charismatic interaction also as transactional? Sometimes people have described, extremely critical.
He was always extremely critical because he had
messaging.
very strong feelings, and he was brilliant. So the advice I always gave to people at Apple about Steve was that 90% of what Steve tells you is going to be bullshit, and 10% is going to be sheer brilliance. And your job is to figure out what the 10% is. And I think that's true. He was equally passionate about the things that he was wrong about as the things that he was, inspirational, that he was brilliant about. He only had one setting.
Fully on or
Fully
something.
on, right.
Yeah. Huh.
So, and I think that was good advice for new people coming to Apple. It was good advice. I felt like it was good advice. Maybe.
But I suppose it would be difficult advice to follow. I mean, you must.
I know.
Have
I was
to
trying to give people difficult advice as to how to really take advantage of Steve without, on the one hand, ignoring him. A lot of people ignored him at their peril,
Right.
and just being a sycophant,
Right.
which I was never interested in. So the sycophants maybe ended up being more successful in life. I don't know, but so this is the way I sort of threaded that needle.
Okay. Well, I think I saw somewhere that you began consulting for Adobe in 1984. Is that correct?
I think so.
Okay.
So I left Apple in 83. After the Lisa shipped. Maybe mid 83. I don't really remember.
Mm-hmm.
And my model of my career, or a career in what we now think of as high tech, at that point in my career was you go off and you spend 4 or 5 years developing a hardware software solution, because that's what I'd done at Xerox, working on the Alto and the Bravo, and that's what I did at Apple, working on the Lisa and LisaWrite and other pieces. And I didn't want to make that commitment of another 4 or 5 years. So I said, I'm going to work for myself for a while, just be a consultant. Coincidentally, we weren't married at the time, but my current wife, who we were together, we wanted to take this long vacation. And I didn't want to get involved in a project where they were going to give me a hard time if I wanted to take a month or two off. And so that was also part of the motivation. So I did consult for a while, and I don't think Adobe was my first client, but I always referred to them as my sugar daddy client because I knew everybody there. I knew Chuck. I didn't know John because he came after I left PARC proper.
Right.
I knew Dan Putman really well. I knew Doug Bratz and lots of other people. And, my model was, I knew Chuck really well because he was the guy who managed me and my college roommate going way back to when I was still in college and I came in and did the printing at night. But actually the person I knew best was Dan Putman, and I could pretty much walk in to Adobe in those days and just sort of wander around and say, I've got some time. Is there anything you need doing? And somebody would think of something.
Okay.
One of the things we didn't talk about in my career at Apple was that I was in charge of networking software for a while. The Lisa was supposed to have a hardware network called, if I remember correctly, AppleNet. And I advocated to adopt the Xerox network protocols, XNS protocols, as our network layer. And I don't know, maybe it was one of those situations where, if you say something needs to be done, you end up being told to go do it. But in any case, I ended up in charge of a small group of networking software people for a while. And so we were in the process of implementing the XNS protocols on top of this AppleNet hardware. Never really came to anything, I don't think, because Apple Bus came along with the Macintosh, and I think Lisa adopted Apple Bus, and the XNS was not adopted, which in hindsight was probably the right decision because TCP/IP came along and sort of swept it away. But the reason I bring that up in the context of my consulting is that since I had gotten involved with networking at Apple, I managed to find some consulting work in the networking space. And so I developed some TCP/IP protocols for various people. I worked for Ungerman Bass. That was one of my clients at some point. This was a period that lasted from 83 to 86. So somewhere in there I worked for Ungerman Bass, and I worked for Stanford for a while in their networking group, and various other people. It was just, as all consulting is, it's just piecemeal, whatever you can find. But whenever I couldn't find something easily, I would go over to Adobe. And so the first thing I remember doing at Adobe was I ported PostScript to the Lisa, believe it or not. Now, why would you port PostScript to the Lisa? It's a piece of software that's designed to run on printers and typesetters and things like that, image setters. Well, turns out that there weren't any devices whenever this was, 84, I guess. Probably 84. The LisaWriter, there weren't any LisaWriters to be had.
Right.
They didn't have the first image setter hardware up and running, which was from a company that I don't remember. And they thought, they being Chuck and John and the other people at Adobe, thought that PostScript was going to be this language that lots of developers used. Huh. Now, in fact, in hindsight, the only people that ever programmed in PostScript were printer device driver writers. But at that point, they thought that they wanted to get it out, the language out, so people could start programming. And so the Lisa was actually a pretty good surrogate for the hardware that was going to be the LisaWriter. LisaWriter had a 68,000, the Lisa had a 68,000. LisaWriter had a megabyte of memory or something like that. Lisa had a megabyte of memory. So they had this idea. It wasn't like a profound part of their strategy. It was just like, wow, wouldn't it be nice if we could have PostScript running on the Lisa, and then we could hand it to people so that they could start writing PostScript before the LisaWriters showed up. And so I did that. And we did get it running, but for reasons I can't remember, it didn't run very well. I think there were some hardware issues or something. I don't remember. In any case, it went on long enough that by the time we got it running, the first LisaWriters started to show up, and then people just used that. So I don't think anybody ever really used that for much of anything. Then subsequently, I think this was still while I was a consultant. I'm pretty sure it was. I ported it to the IBM PostScript again, to the IBM PC. And this was pretty much in support of the sales team who was trying to get IBM to adopt PostScript. And it's not, again, it wasn't that they thought that the IBM PC was ever going to run the PostScript language in that form, but IBM was going to develop printers, and inside the printers were essentially going to be, PC hardware of some sort. And so IBM wanted to know if you could run PostScript as part of the negotiation for this OEM contract. They wanted to know if they could run PostScript on the PC. So I got it up and running on the PC.
That's really interesting, because in both cases, it really, of putting it onto the Lisa and putting it onto the IBM PC, it really does highlight the fact that in these laser printers, they were powerful computers that happened to print.
Yeah.
And it really does.
Well, the LisaWriter was more powerful than the Macintosh at the time it came out, I'm pretty sure.
Yeah.
Or they both had 68,000s, but it had more memory. And the truly extraordinary thing about the LisaWriter, or the radical thing about the LisaWriter, was that it had this huge program in read-only memory. It wasn't programmable read-only memory. It was read-only memory that once you shipped that printer, if there was a bug in the PostScript language, it was going to be bad news.
Yeah.
So that was pretty radical at the time. I don't remember how much read-only memory and how big the code was, but it was at least hundreds of kilobytes. A lot of code, many thousands of lines of code, much more complex than people were used to putting in a non-volatile, non-changeable memory.
Right.
So I did projects like that. I don't remember what else I did as a consultant, but in spring, early summer of 1986, my hire date was in June, so it happened somewhere before that. Two things happened. First of all, the way I describe it is the rabbit died. You know what that expression means?
No. Oh, yes, for a pregnancy test.
Yes, right.
Yes, yeah.
Not very many people know that expression anymore, but in any case, my wife became pregnant. We were married in 85. She became pregnant in 86. And I had already taken a part-time permanent position at Stanford in the networking group so that we could have health care. But it was like, okay, I'm going to have a kid. I better get a real job with health care and blah, 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 blah. So that was the first thing that happened. The rabbit died. The second thing that happened is that Chuck came to me and he said, you know, Tom, we're going to be going public here pretty soon, and if you think you might ever want to join Adobe as a regular employee, this would be a good time to do it.
Very nice of him.
Yeah, right. So the stars aligned. I became a full-time employee. My daughter's 32 now, 31. Let's see, 1987, 31, I guess. And that all went fine.
Good.
And then I spent the next 26 years at Adobe.
Well, what were your initial roles within Adobe?
Mm-hmm.
The first things that you were working on? I saw some indication that it may have been typefaces. Is that wrong?
No, it's true.
Okay.
But the thing I used to say about my early days at Adobe was that I was the only person at Adobe that could spell PC. Because in my consulting, you know, I'd worked at Xerox on the Alto, I worked at Apple on the Lisa. None of that had anything to do with the IBM PC, but the IBM PC is happening over this time, right? You know, like Windows 1 probably came out in about 83, I would think. Wasn't it 81?
I think it came out in 80. It shipped in 85, I think. I
Windows?
could be wrong. I could be wrong.
Maybe, because I wasn't working on Windows in my consulting. I was working on DOS. But, you know, that networking work that I did was on DOS, and other contracts I had, I had a PC in my home office. So I knew how to navigate around a PC, and nobody else did it. PostScript was developed on first on a VAX, I think, and then on Sun workstations. Right. Anybody that wasn't working on PostScript was probably working on the Macintosh because of the LisaWrite and the Apple connection. The typefaces, which were their first product, the second product after PostScript, were first released on the Macintosh. When I arrived in 86, Mike Schuster was working on the first version of Illustrator for the Macintosh. So, since I knew how to turn on a PC, my first jobs were in taking things that were running on the Macintosh and getting them running on the PC. So the first thing was the typefaces. There wasn't much software associated with the typefaces, but we had to have software to download to the LisaWrite and to the typesetter, image setter, and probably some installation software. Who knows? It was very simple stuff. But so my first product release at Adobe was the typefaces for the IBM PC. Got it. And then I went on from there, and my next project, which was a big project, was to try to get Illustrator to run on Windows. Right. So I ported Illustrator to Windows, and I built a team to do that. And the first attempt at doing that was from a computer science point of view, it was extremely elegant and ambitious, and from a practical point of view, it was totally useless. Why? Because this was, I don't remember what version of Windows, but it was an early version of Windows, still running on 640K PCs. They had this hack where you could map. You could have more physical memory than the 640K, but you had to map it from the application into this one or two 16K blocks up above 640K. Maybe there were 4 of them, I don't remember. In any case, not much memory. And so we have Illustrator. It's running on a 1 megabyte Macintosh. And I think, I'm not sure the bitmap for the Macintosh was actually in that 1 megabyte. It might have been in some other part of the address space. I'm not sure about that. But in any case, now we've got Illustrator. We want it to run on this IBM PC with 640K, and it's got to have Windows running. It's got to have DOS in there. It's got to have Windows in there. It's got to have the bitmap for the display in there, I think. I'm not sure. Anyway, it was maybe half the memory space of the Macintosh when all was said and done. No, of the Lisa, excuse me. Of the LisaWrite. I'm getting confused here. How did that work? I guess it must have been so Illustrator was released for Macintosh was released in 86. So by then there had to be at least a 512K Mac.
There definitely were.
Yeah. So we'd have to go back and resurrect the numbers. Anyway, it was hard. There wasn't as much space for Illustrator on a PC running DOS and Windows 2 or 3 or whatever it was as there was on the Macintosh. So I huddled up with John Warnock, and he clued me into this data structure that he'd used on flight simulators. In a flight simulator, you have this huge world, right?
He had a table too, didn't he? Is that?
Yeah. But it's a different data structure entirely. It's where you carve up either the 2D space into quadrants and recursively divide the quadrants, or he was doing flight simulators, so he had a 3D space into, I guess you'd call them octants. Anyway, I said, well, John, what do you think about, maybe we'll take the Illustrator image, which needed, a pretty big, could get fairly complex, and we'll carve it up into these quadrants recursively, and then we'll put it on the disk, sort of like we did, with word processor documents, and then we'll swap in the pieces that we need to display just the piece that's on the screen. And we got that working. It was a very elegant data structure, I think. The problem is that unlike flight simulator worlds, a very typical use case was to want to see the whole Illustrator picture. At which point, it was way slower because you had to read everything off the disk. You constantly, it just thrashed.
I see.
And so I'm not sure that version of Illustrator ever saw the light of day. Maybe it did, maybe it didn't. But I think maybe we shipped it, but it was a miserable failure. And so time passes, Moore's law acts on the world, and Windows, the amount of memory on PCs gets bigger. Windows develops into sort of a real live operating system layer, and it can map memory. And I'm sure virtual memory came in there at some point. And it wasn't until, I don't remember what the dates were, but it was probably more like 89 before we had a viable version of Illustrator on the PC that really worked well. It's like Illustrator 3 is what I remember on the PC. Illustrator on the Macintosh was being extremely successful all along, but the one for the PC really didn't take off until about Illustrator 3.
And is that what you were focused to in that period? Illustrator for the PC?
Probably at that point, yeah. Because the first big pivot for me at Adobe was Adobe Type Manager. So there's plenty of drama around this story.
Oh.
In 88, or 89, Apple announces that, so we had this typeface format called Type 1.
Right.
Apple announced, and it was only for printers and image setters. The screen was still using bitmap fonts on the Macintosh and on Windows. Every obvious desire is to have scalable fonts on the screen, but at the time it's a very hard problem because it was hard to get quality looking type on 300 dot per inch laser printers, and now we're talking about getting quality print on 72 or so dot per inch screens.
Right.
So we're feverishly working to adapt the software that renders Type 1 fonts to work on the screen, expecting that, well, our PostScript is an emerging standard. Type 1 is going to be a standard as well, and that's going to be wonderful for Adobe. But Apple didn't want that. They didn't want our format running on the Macintosh. They didn't want our software running in their operating system. And again, you'd have to ask somebody like Chuck and John to reproduce the history of the interactions. They were actively trying to convince Steve and the powers that be at Apple to adopt Type 1 and take our typefaces. And, we had dollar signs in our eyes. It was like, well, they're paying us a royalty for the LisaWrite now. What if they pay us, even if it's a small royalty, what if they pay us a royalty for every Macintosh? Well, you can see why maybe they didn't want to do that. So this goes on, and let's say it's happening in '88. I don't know when it's happening, these discussions. And there's a famous Siebold conference where Apple gets up and announces that they're going to create their own scalable type format, TrueType. And I think it was even at that early meeting they had already lined up Microsoft as well to embrace the standard with them. So now all of a sudden the two major personal computing platforms were going to have a new scalable type format, but it was not our scalable type format. So John had a very emotional reaction at that Siebold conference, and he came back and basically said, he and Chuck said, well, we have to get our software running and our fonts, typefaces running on the Macintosh ASAP. We have to beat them to market. And they asked me to lead that effort. And it's one of those cases for an engineering manager which is pretty idyllic, where I say you get the golden finger. You can walk around the company and you can point at anybody and say, wow, guess what? You're on my project now. And so, it's more complicated than that. Obviously, people were involved, and if they didn't like being pointed at with a golden finger, then you had to deal with that. But basically, from the point of view of Chuck and John, I had a golden finger. Just go find anybody in the company to make this happen ASAP. So I pulled people from my team. Mike Schuster joined us. Bill Paxton was part of it. I don't think he was ever formally part of the team, but he's the one that came up with the initial enhancements, I think, to the rendering algorithms to make them work at 72 dots per inch, more or less as well as they did at 300 dots per inch. I subsequently made some additions to those algorithms that we patented and got factored into the core algorithms. So that was one big piece of the puzzle, but there was this other big piece of the puzzle, which is probably pretty foreign to people today because it's virtually impossible to do. But we were a third-party software developer, and we wanted to basically add something to the Macintosh operating system. Think of it that way, right? Because we didn't just want our applications to get the benefit of scalable fonts. We wanted any application that used fonts to have those typefaces rendered at any point size using our software and our scalable fonts. So that meant we had to basically splice ourselves into the Macintosh OS without the cooperation or even the over the objections of Apple, because they have a different strategy. So we had to reverse engineer the Macintosh operating system and figure out how to find the places where applications were calling to have things rendered onto the screen, patch those places, and then have our software take over at the appropriate times or defer to the bitmaps if that made sense.
So this would have, if I were a Macintosh user and I installed this
Adobe Type Manager, yeah.
Adobe Type Manager, would I be altering my system?
Essentially, yeah.
Okay.
Yeah. It's like, I mean, you could think of it as sort of like installing a device driver.
Okay.
Except we weren't using an agreed upon device driver interface. We were just hacking into the system.
Okay.
So it's more like a virus in some ways, right?
Yeah.
So figuring out how to do that, nobody knew how to do that. Certainly Apple wasn't going to help us figure out how to do that. So there were two big pieces to the Adobe Type Manager project initially. One was to revise the algorithms to get them to work at lower resolutions acceptably, and the other was to figure out how to hack into the operating system and install ourselves as a virus. And we did both of those things, and we shipped that product in something like 6 months, incredibly fast. We'd have to go back. I mean, yeah, we'd have to go back and look at the history books, but it was and we beat them to market. And Type 1 fonts were the more important typefaces on the Macintosh until TrueType really matured. And if you fast forward a long time, I don't know how many years, a decade maybe, as a result of that, Apple and Microsoft as well had to support Type 1 fonts even when all these hacks got removed and even when we weren't supplying them with the software to do it anymore. They had to interpret those fonts because the industry was dependent upon them and expected them. So we won in that respect. I mean, we succeeded in salvaging our format as a standard. It was a secondary standard over time as TrueType matured. And as a business, the existence of TrueType and the business motivations of Microsoft and Apple, i.e. they didn't really care about making much money off of typefaces. In fact, they didn't. They bundled their typefaces. It kind of eviscerated the typeface business, which is what we were interested in. We weren't doing this because we wanted to have our software running in the Macintosh. We were doing it because we wanted to sell typefaces. That's what we made money on, and then have them used on the screen.
Right.
So, at its peak, the typeface business for Adobe was probably tens of millions of dollars a year, but it's one of those businesses that came and went fairly
it still
quickly.
continues to this day, does it not?
Yeah, but I mean,
not with the
but it's not an
centrality.
important product line for what is Adobe, $6 billion company today?
Yeah, who knows? Yeah.
So it's just one of those sort of legacy things that will never die, I don't think, but
Right.
But became immaterial to the business fairly quickly. I mean, $20 million a year in 1988, 89, 90, that was probably a percent or two of the business. I don't know.
Right. Well, it was definitely. I mean, my impression is that this project Adobe Type Manager project was, a huge priority for Adobe at the time.
Yeah.
I mean, just, and I suppose, maybe this is wrong, but it didn't turn out that the long-term, financial benefits of the success of Adobe Type Manager, it maybe wasn't that the upside was so huge, but that at the time,
It was a
circa
incredible
19,
threat.
that's right, the downside would have been so dramatic.
And it could have threatened the PostScript business, which was much larger. And is probably still larger today. I don't know.
Why do you think that they asked you to take, to shoulder the burden to get this thing done?
I don't know. You'd have to ask Chuck and John.
Were you
I was
surprised?
good at my job.
Well, yeah, right. I just wondered if you had, it must have been, it's a big job to get. And I wondered, did it surprise you that they asked you, or did you feel like, yeah, that's right, I'm the one to do it?
No, I don't think it surprised me. I was still young and cocky and ambitious. And the one that surprised me comes later when they asked me to take over the advanced technology group. We'll get to that eventually, but that one surprised me.
Well, I wanted to ask, so you had this kind of, I suppose, like this this crash project, or this intense project, and playing it out during the font wars, so to speak. I was interested in where PDF starts to emerge in this milieu, or what was your involvement with?
I was not very involved with PDF in the early days.
Okay.
So that would have been the early 90s, I think. Or, yeah. So now my grasp of dates might get a little looser, but whenever they happened, I went from Adobe Type Manager to being in charge, I think maybe of all of the application software. I'm not sure, from an engineering perspective. That wasn't much then. It was like Illustrator and typefaces and Adobe Type Manager, I think. But somewhere in the early 90 time frame, I took over all of type, not just engineering, but production as well. And that was a fun job. So during that period, in addition to managing all the Adobe Type Manager stuff, from a software perspective, and managing the typeface library, we were building type tools to develop Asian fonts, Japanese fonts firstly, and then Chinese fonts. And so that was exciting and challenging, and I got to work with designers and production people. That was a fun variation on my normal work. And it was during that period, I think, when I was in charge of the type group, that John and Bob Wolf and a bunch of other people were doing the first version of Acrobat. Bill McCoy.
Yeah, that would make sense.
Yeah. So I really didn't have much to do with it.
Okay.
Then my involvement with Acrobat started in the mid 90s, or even late 90s, probably mid 90s. So I just said wonderful things about running the type group, and they're all true. But for a technologist, it's kind of a dead end. We developed these tools, we developed these rasterizers. The way I describe type technology or the type business is that it's a 400-year-old business that's had a few technological discontinuities, like 3 or 4, Gutenberg being one, and scalable type and raster-based image setters being another, and there weren't that many in between, and the periods of innovation were not that long. So we sort of solved the problems of scalable type for all practical purposes between when Adobe was founded in '83 and maybe '93 or '94 or '95. There just weren't that many interesting technical problems to solve anymore. And so I found myself in this career juncture of, well, I'm getting more and more management responsibility, but I'm not really challenged very much technically. So I made what I think in hindsight was a fairly radical choice. I turned over the typeface management to somebody else, and I went back into the advanced technology group that was being run by Jim King then, essentially as a free electron, unassigned individual person. And it was just a place where they let me park for a while I figured out what to do next. And what I chose to do as an individual was develop what we today would think of as the security features of Acrobat. So I developed, first of all, I went off with a marketing guy and licensed all the crypto libraries from RSA. And then I built 2 suites of features on top of, inside of Acrobat. One was for doing encrypted secure documents, but with distribution lists. So I was using public key cryptography, which was pretty cutting edge at the time, to attach a distribution list to a document in such a way that only the people on the distribution list could open the document. And that was pretty radical and pretty innovative for the time. And the other feature was signed documents, which are used to this day. And again, I used public key cryptography, so we went off and licensed the RSA libraries, because if you were just going to do a password encryption on a document, you could just use standard. You could implement your own encryption and decryption algorithms, but to do public key, you'd want somebody who had really poured over that code. So we licensed that code. I implemented those features as an individual contributor inside of the Advanced Technology Group. And then the Acrobat team picked those up and put them into the product. Probably re-engineered the whole thing before they did it. I don't know, but
could you speak a little bit about why at this moment, or how you became focused to these issues of security at this moment? Was it
again? It's all just serendipity. When I was a master's student at Stanford, I took a graduate study group, kind of reading group seminar from Bob Metcalf, and we read papers about networking stuff. And one of the papers I read was Diffie and Hellman's paper about public key cryptography. So it was in the back of my mind. I knew a little bit about this public key cryptography, and I thought, well, this is a good match for me. It's a meaty technical problem. I had a vision for how it would fit into the Acrobat application with these 2 features. I had enough management expertise or pluck or whatever you want to call it to not be intimidated by going off and licensing the library, or wrangling this marketing guy to go with me to Redwood City and tell him we wanted to license this library. And so I did it.
And I suppose it's also kind of inherent in the very notion of PDF. What is that for? Distributing documents,
Oh,
electronically.
it
so
fits into the
fits
vision for PDF for
perfectly.
sure, but nobody
Yeah.
else was making that connection
Yeah.
in 95 or whatever it was, 96, I don't know.
Mm.
So it's just is a project to keep me busy. And it turned out to be really successful.
Did that also, that time when you were working on that as an individual contributor, did that also give you the opportunity to kind of see everything else that was going on in the advanced technology group?
Yeah, sure.
Yeah.
It wasn't that big a group, so.
Okay.
And I think I was aware of it before, but it was a pretty small group at that time.
Oh, okay. I hadn't realized that it was.
Well, the original vision behind the Advanced Technology Group was the following. Company was founded by these world-class researchers from Xerox PARC, like Bill Paxton and Doug Bratz and other people of their ilk, whose names I should remember, but Ed McCreight was there by then, I think. And in the startup phase of the company, it's all hands on deck. You do what has to be done. So these world-class researchers were basically talking on the phone to OEM customers and fixing bugs in PostScript. And so as soon as they could afford it, I think Chuck and John wanted to have a little walled garden where these people could go off and maybe think about something a little more substantive than, how to fix the latest bug that was preventing the last OEM to call from shipping their product.
Right.
And so that was the vision, and then there weren't that many people at that time like that. So, so that's where those people went, and they worked on the things that were important to them. That's where Bill Paxton was when we did Adobe Type Manager, and since he had done the original rasterizer for PostScript, font rasterizer, type rasterizer, it was there that he developed his improvements for the screen rasterizer. I don't remember what Doug Bratz was doing or Ed McCreight, but it was just their little walled garden.
Interesting.
Jim King came at some point, maybe in the early 90s, I don't know. And he hired some more people, but that was the sort of founding principle. So it was probably bigger than just that handful in 95, but not that much bigger.
And was it right after you did the kind of handed off the security work with PDF to the Acrobat team? Was it at that moment that you were asked to lead the advanced technology
It
group?
was more or less at that point.
Okay.
I don't remember anything significant happening between those two events, but
Okay.
Actually, I was lobbying for a different job.
Which was?
I wanted to be the VP of engineering. And that's a job, and I think it was for the whole company at the time, because I think they were formalizing a functional organization for the whole company before there was any divisions.
Right.
And I was lobbying for that job. Smokey Wallace ultimately got that job. And John came to me, and it seemed like kind of a consolation prize at the time. He said, I don't want you to do that. We're giving this job to Smokey. I think he's better qualified for it. But I want you to go off and lead the Advanced Technology Group. So I said, okay. I never thought of myself as a researcher. And it was called Advanced Technology at the time because we didn't really call it a research group, although it is very much a research group now and evolved that way during my tenure. But that's how I ended up with the job.
And you were with that in that role for
Till I retired.
till you retired,
Yeah.
which was in 2013.
13.
Well, could you talk about, I mean, on the one hand, listening to you talk about it as a walled garden for these, highly skilled people, that sounds like a leadership challenge to me. You have, well, I guess the whole thing about sort of research management is a continuing conundrum that groups grapple with. How
right,
did
and
you?
we had, for the time, I think, a fairly unique perspective on it.
What was it?
So, when I would talk about managing research groups inside and outside of Adobe, when I was in that position, I would say that all research groups have the same top 2 priorities. One priority is to advance the state of knowledge in your discipline, be at the cutting edge, probably have good working relationships with academic research, things like that. So it's what I call the outward-looking priority. The other priority is an inward-facing priority of being relevant to the company that's supporting you in a corporate research context, and that means having an impact on their products and services. So I say everybody has the same top 2 priorities. How do you distinguish between any research philosophy or practices based on that? And they said, well, the way you do it is you turn to the research manager and you say, okay, I understand you have those top 2 priorities, but what's your top 1 priority? And research groups always fall into, I think, pretty much into one of 2 camps. Either the outward focus, research focus, advancing state of knowledge, working with academia is the top priority, and being relevant to the company is a secondary priority, or vice versa.
Right.
And if you looked at the prominent research groups of the time, most of them were of this kind. The outward-facing priority was the most important. IBM Research, HP Labs, Microsoft Research, probably even in those days. Certainly during most of its history, if not to this day, that was their priority. Sun Labs was a little different. I don't know, Intel Labs, if it existed, I'm sure was of this kind of priority. We, very deliberately, had reversed those priorities. And our top priority always was to be relevant to the company. And I think Chuck and John established that that philosophy based on their experience of being in a research organization, and then feeling that they needed to leave that research organization in order to do what they wanted to do to have an impact on business and society and get their research results into the hands of people. And I think I took that vision to an extreme in the sense that it was my mantra throughout my entire dozen or so years of tenure that both internally and externally, this is our priority. And so you talked about managing these very talented, perhaps high-strung technical people, and I was straight with them every day, in and out. It was like, I love what you're doing, but it's got to be relevant. It doesn't have to be relevant tomorrow.
Yeah.
It has to have an impact on the company. My time frame is 3 to 5 years. If you've been working on something, or if you've been working in the advanced technology group for years, and you've never transferred any technology, or you've never had an impact on a product, or people on the product teams don't come to you for advice, then you're not succeeding. And so we just inculcated that in the culture. People knew it when they got interviewed. People knew it when they got reviewed. when they got raises, when they got stock options. And so that was our culture, and that's why our challenges, my challenge as a vice president of research, although we didn't call it that then, of advanced technology, my challenges were the opposite of most of my peers in the industry. I think they would view their biggest challenge as, justifying their budget to corporate and trying to get their people to do something that corporate thought was valuable, as opposed to just hobnobbing with their friends at universities, collaborating with their friends and colleagues. My challenge was, certainly I had to keep beating that drum, but it was so ingrained in that almost everybody was in my group was always looking for those opportunities. And my challenge was to make sure that we didn't fall into just being the 13th developer on a project. Yeah. And I don't think we ever did, but that's what I would think about. So that was our philosophy. We were inspired by Bert Sutherland at Sun Labs. I think he had might not have been quite as militant as me about it, but I think he was very attuned to being considered useful to Sun. I had a very early meeting when I first took over the Advanced Technology Group with him, and he sort of gave me some pointers, and we incorporated that into our practices and philosophy. And then, over the course of a decade or so, we actually were able to evolve all of the outward-facing strengths that perhaps we had de-emphasized or not emphasized in the early days. So David Salazin was a key hire that I made early 2000s, I guess, I don't know. Mm-hmm. And he came in and really codified for us how to work with universities in an effective way. And I think we had, again, a kind of a different approach to working with universities than... Well, what were the differences? The first and most important difference was that we insisted there be an honest and bona fide collaboration. So money changing hands was of zero interest to us unless there was a collaboration. So our collaborations tended to be, our university collaboration projects tended to be smaller scale, but we had more skin in the game. Now, we weren't like an Intel that was going in and dropping $100 million on Stanford to build a fab or something like that. We were identifying like-minded professors and students to our own advanced technologists and researchers, and they were working hand in hand, elbow to elbow on some interesting project. Not necessarily a project that was going directly into a product, but nevertheless, they were working together on it. So collaboration was the first key. The second thing that I think that David figured out that was critical was the intellectual property model. If you are a research manager and you want to collaborate with the university, your worst nightmare is getting their lawyers or your lawyers involved in setting up the collaboration, because it's guaranteed to come to a screeching halt and maybe never happen. So what we did, this is David's inspiration, what we did is we convinced our lawyers that we didn't need an intellectual property agreement with any of our university collaborators. and that we were going to be just fine because every collaboration we did, every project we did with the university was a bona fide collaboration with somebody that was employed by Adobe, and therefore the fruit of that research project, which the intellectual property fruit, which was almost certainly going to be a patent, first a paper, then a patent, was going to have an Adobe employee's name on it. So we didn't have exclusive rights to the work that happened in university collaborations, but neither did anybody else.
Right.
And we had equal rights to anybody in the university. And we convinced our lawyers that this was a valuable trade-off to make. Give up the exclusive rights in exchange for them not having to negotiate with the university's lawyers, impossible terms for sharing intellectual property that didn't exist at the time that the lawyers were involved, and therefore they were going to bring all of their expertise and power to bear to make sure that every unanticipated consequence was accounted for. So that was the second thing. Then a third thing that I think we got right is we really focused on an internship program that was unparalleled, at least at Adobe. In the advanced technology group, when we were, say, 75 people in, say, 2010, when this was sort of at its height, we might have 40 interns.
Wow.
There might be 30 interns because Adobe wasn't that good at, didn't have a great internship program at the time, company-wide, but we would have maybe 40 interns. And that had some obvious benefits and maybe not so obvious benefits. The first obvious benefit is it was a great recruiting tool. The not so obvious benefit is it played into this intellectual property strategy that we had, because now the graduate student, who in fact is the one that does all the work anyway in the university, is spending a significant part of their time on the Adobe payroll. And so the energy they invested, the intellectual property they developed while they were an intern, was Adobe's exclusively. And so now the intellectual property conundrum was solved in an even more powerful way. The lawyers were even happier. And we had this, we really believed that supporting the students was more important than supporting the university or the faculty members. Faculty members didn't usually agree with that, but and they were treated as such a commodity financially in the university community. We would, pay them in 2010. We pay them $190, $100 an hour for 10 weeks, and they'd make more money in their internship than they did in their whole year as a graduate student. So we felt we were doing a real service to the community that far outweighed what the professor really wanted, which was for us to give him tens of thousands or hundreds of thousands of dollars to run his lab. And we did some of that, but not nearly as much as hiring interns. So that was probably the third and maybe the last big innovation we had in terms of university collaborations. And credit for that all goes to David.
That goodwill multiplier for those graduate students from that treatment must have been unbelievable.
Yeah, it was fabulous. Yeah. But we could only do that as our staff in the advanced technology group matured enough to want to go back to having those university collaborations, because we kind of beat it out of them in the 90s, right? It was like, well, if you come to Adobe, you're becoming you're leaving research and becoming an advanced technologist. But then we sort of had to reintroduce that and let them know that it was okay. It was valued. University collaborations were valued, and we wanted them to mentor graduate students and collaborate with faculty members. And it took us a while to sort of get that back, but we did. And I think in all modesty, I think it's the most powerful research model that I've ever come across. Well, much more powerful than sort of the standard one where poor research managers constantly being beat up by executives about how much money he's spending, and by product teams saying, we don't get anything from you yahoos over in research.
Well, listening to you, it's an interesting way to, because it's not you, telling other people, oh, I think you should, go in this direction or that direction to be, directly relevant to the others in the company, but rather saying, it's up to you, dear member of the group.
That's right.
Because to go out and find the thing that comports with your curiosity and inclination and talent.
Exactly. Because they're senior people. You can't go and assign them to create the next innovation for Photoshop. Either they're into it or not. And if they are, then they'll find that innovation as long as you have the sort of infrastructure to help them meet the people in the product teams. I had lab managers who were really charged with, trying to do this matchmaking process. But yeah, the individuals got to choose themselves, and they got this, what I thought was a fairly liberal time frame to demonstrate success. And it was extremely, extremely successful in the sense, from my point of view, because I don't think anybody ever had an easier time during budget planning than I did, because the product teams, by and large, would go, when I was sitting on the executive staff, the business unit managers would look at my budget and say, is that enough?
Yeah. Enviable.
Now, I got to be honest, we weren't as successful in all disciplines as I would have liked, but the general model was those folks in ATG, they produce, it's a, in the context of then a $4 billion company, it was a pretty insignificant amount of money. I don't know, $10, $20 million a year, I forget. We just had all these advocates in their engineering teams. It was like, don't mess with those people over in ATG. They're the ones that produced, this feature for Photoshop and this feature for Acrobat and this feature for Premiere. So,
also being very diligent, I would think, about protecting, if you will, the poor people in the product groups from that kind of 13th developer or whatever you called it. This super developer, that has a lot of maybe like weight and status in the overall company. To make
that was part of the culture too.
Yeah.
Because my people were senior, because I gave them all this latitude in exchange, or what I demanded as part of that is, it's your responsibility, the researcher, to figure out how to get your technology into the products. Some of you are going to have a very easy time. You are going to, metaphorically speaking, you are going to set your work product outside your office door when you leave, and when you come back in the morning, some earnest product engineer is going to have integrated into the product. God bless you. I'm glad it was so easy. But some of you are going to have to work hard, and you're going to have to, sit side by side with the product team through the first release and maybe the first or couple releases, and make it work. And if that's what it takes to be successful, that's what I expect you to do. So I did have, in many things I was very undemanding. What you work on, how long it takes to prove viability. I think I was very flexible and patient, but in terms of having people committed to the end result, I was very demanding and very unforgiving.
That's fascinating. I wanted to ask you, in the time we have remaining, about maybe, well, 3 questions. One is about the culture of Adobe, which John Warnock and Chuck Geschke talk a lot about. And I just wondered how that, your take on the story of Adobe culture, its importance, its
Well, I don't think
nature.
I would have stayed at Adobe for 26 years if it had a culture like, should I name names?
It's up to you. Other companies.
Other companies. Well, Oracle was, from our generation, Oracle was probably a very contrasting culture, very kind of hard-nosed and unforgiving and demanding. I think Chuck and John are 2 very humane individuals, and they brought that humanity to the culture of Adobe, and it meant it was a nice place to work. Even when we were, there were fights and feuds and disagreements, there was an understanding that we were all on the same team, and there were Chuck used to have this expression, everybody sweeps the floor at Adobe. I don't think everybody did sweep the floor at Adobe, but it sets a tone. And so it kind of took the air out of a lot of prima donna behavior or privileged behavior that just made it a nice place to work.
And I also wanted to ask you just about, if you could provide some characterizations or reflections on the 2 of them, John Warnock and Chuck Geschke. Just impressions,
Well, they're just 2 of the finest individuals that I think I've ever known. I mean, as I said, I just described them as 2 very humane individuals. I could try to find more adjectives, but they're just genuinely good people, and even when they were being executives and making tough executive decisions and competing aggressively, their humanity was always right there, close to the surface, and they just inspire loyalty and trust, and they're just, as I said, I can't imagine having worked there for 26 years if it wasn't for them and the culture that they established.
Well, then perhaps I'd like to ask you a little bit about your life outside of Adobe, just your other interests and activities outside of the context of work.
Well, I don't have
a
Adobe life anymore. It's been 5 years since I'm retired.
Well, I mean, but while you were, just over the course of your life, have there been, and today, any particular passions or interests?
Work, family, it's kind of the usual list of things. Adobe had a very nice policy that came about in the mid-'90s when we acquired Aldus.
Yeah.
Aldus had a 6-week sabbatical program every 5 years. Adobe had a no-week sabbatical program, and so the compromise was that we ended up with a 3-week sabbatical program at Adobe, which is true to this day, I think. Every 5 years you get 3 weeks that you have to take all at once. And that, every 5 years, became a really important part of my family's life because we would always go on some big trip. I actually went on the first sabbatical ever. I know because the sabbatical program didn't start until January 1st, 1995. The acquisition was in 94, I think. And I left on my sabbatical before the holidays in 94 because I was taking 6 weeks, not 3 weeks. And we went, my family and I went to Ecuador for those 6 weeks. Had a great time. And then in 2000, we went to Africa. And 2006, my wife and I went to New Zealand. And in 2010, my wife and I went to Italy. So that was an important part of how we lived our life. It was not a very frequent thing every 5 years, but it was something that we all looked forward to. I didn't have that many outside interests. I have more now that I'm retired.
What do you care to share?
Sure.
Yeah.
I have two main structured outside interests in my retirement. The first is that I wanted to spend more time outside, outdoors, and so I'm a docent at Stanford's Jasper Ridge Biological Preserve. And I lead tours and I help out on various projects over there. But for the sake of this conversation, probably the more interesting one is that I volunteer at Woodside High, helping to teach AP Computer Science. This is my 5th year doing it. It's really a big part of my retirement.
And so do you do that does that run throughout the school year every year? Okay.
Yep.
And was I know in some states it's harder than others for somebody without some sort of like educational credentials and certifications to teach in a public high school. Was that something?
Well,
that
I
you
don't
faced?
teach. I co-teach or assist. So there is a
That's a
teacher
great
in the
workaround.
classroom. But also there is an organization which deserves a plug here called TEALS. I don't know whether you've ever heard of it.
I haven't.
And it's a nonprofit founded by a guy out of Microsoft. And the whole vision behind TEALS is to take professionals in industry and match them up with schools and teachers to bridge the expertise gap that prevents schools from having a computer science curriculum. So it's not just AP Computer Science, there's Intro to Programming, and there's now AP Computer Science Principles. And at Woodside High, there's even a 4th class that's kind of unique to Woodside. But TEALS is the organization that does that matchmaking. So the way I ended up at Woodside High is I found TEALS. I said, I'm interested in volunteering, and they said, great. Here's the guy to talk to at Woodside. And that's a huge, huge lubricant in the process because if you just call up a random high school and say you want to volunteer, I guarantee you'll get nowhere.
Right.
You'll get a very polite, thank you very much, don't call us, we'll call you. So they know who the computer science teachers are. They know if there's a department head. They know who that is. If there's a instructional, whatever they call them in high schools, vice principal or something like that, they know who that is. They know what classes they aspire to teach. They know what the skills of the accredited teachers are and what their skill gaps are. So they know how to put together a package of volunteers and curriculum and other things that really greases the skids to make this happen. And they operate in hundreds, if not thousands, of schools around the country. Mostly, they started in the Bay Area and in the Northwest, but they've expanded beyond that for sure now.
And how would you characterize, what led you to, connect with that organization?
Well, it wasn't a straight line, and it didn't happen overnight. So, as I said, one of my priorities when I retired was to spend more time outside, and that was easy because I happen to live next door to Jasper Ridge Biological Preserve, and my wife has been a docent for many years, and so the obstacle to me becoming a docent was that I actually have to train to be a docent, and I didn't have time. I didn't feel like I had time to take the training when I was working. So I started that immediately upon retirement. That was easy. The other area that I told myself I was interested in, objective I set for myself, was I wanted to do something in education. And my first idea was that I was going to be a math tutor or something like that. And in fact, I did. I tutored at one of the local high schools. A high school, it was a very spoiling experience because that high school was very, unlike other high schools, it was very well organized and set up to take advantage of volunteers. And, you know, they got a commitment out of the kids to show up when they said they were going to show up, and we met at regular times rather with an individual student over, you know, a period of months rather than, there's also some models where you just sort of show up at a bullpen and wait for kids to show up. It doesn't work very well. Right. So I did that for one semester, you know, the spring semester, and then they were so well organized they didn't need anybody the next year. So the next year I tried doing something at another nonprofit that was not a school, but it was an after-school program. Yeah. And that was more like the bullpen situation. I didn't do that for very long because I would have to drive all the way over to East Palo Alto from Portola Valley, and I'd sit there and maybe somebody would show up and maybe somebody wouldn't, and then I'd have to drive back through traffic. So I didn't do that for very long, and then I was just trolling the web looking for volunteer opportunities when I came across Teals. This was also mid-academic year, and I just, about this time, or maybe in January, I filled out an online application, and you know the material on their website seemed very clear that you had to take some training and start at the beginning of the year, and you know they wanted to make sure you were really committed, blah 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 blah. So I just filled out this application. I figured I'd start the next September at some school. I hadn't even identified Woodside as the school, and I think maybe my resume was a little different than the average volunteer. So I got a call or an email back within about 24 or 48 hours. And said,
I'm not surprised.
We think we could fit you in right away. Yeah. And so I started whenever that was, 5 years ago. So probably, it couldn't have been, it must have been 2014. Might have been even 2015, I don't know. And I've been doing it ever since. But I'm never in the classroom by myself, and that's why I don't have to be accredited.
Right, that makes a lot of sense.
And it's good for the volunteer too. It means that I don't have to deal with the administrivia, and I don't have to deal with any awkwardness about, you know, interacting with young adults, right. That sort of stuff. Yeah. Because I'm never alone with them.
It must be also, well, to have done it for 5 years, you must be finding it rewarding. So
I do.
I wonder if you could just, say a few words about, if you can characterize, why it is rewarding.
Well, there's a couple reasons. I mean, I enjoy working with young people. I enjoy tutoring, and a big part of being a co-teacher or assistant teacher is tutoring because it's a hands-on class. So most classes, the kids are at the computers working on programming projects. Okay. And so my job is just to circulate around and ask them how they're doing, and when they're stuck, to help get them unstuck. So I did that with my kids in math, and which is why I thought a math tutor would be nice. But now I do it in an area that I know even better than math, and so hopefully I'm even better at it. So there's that. The other thing is that I've probably took a slightly unusual approach to my mission in that I've actually been developing curriculum as well. Wow. in the form of projects, and so I've developed 3 or 4 projects that the kids do, and so then I get to program and I get to test these things out. I get to build libraries for the projects. And I find that even after, let's see, it's going to be 50 years next year since I learned how to program, that I still enjoy programming. And so that's a real draw for me. I don't know that I'll do it forever, but I'm still enjoying it now, and I've really found it rewarding over the last 5 years.
Well, maybe this is an appropriate time to break.
Great.
Well, actually, before we do that, I'll ask kind of a catch-all, a safety, a cover myself question,
Yeah.
which is there anything that I haven't asked that I really should have asked you about? Do you feel that we've...
Well, there's only one story that I can think of that I
Please.
didn't get a chance to tell, and I think it's an educational story, and it's got to do with Steve Jobs and Larry Tesler and Lisa and the Macintosh. So we were looking for things to say about that period of my career. So there was, as I said, lots of drama in the early days of Apple, lots of pivots and false starts, but one of the bigger dramas was around, we had a mouse, but we had to decide how many buttons to put on the mouse. You're probably familiar with this decision. For context, the Alto mouse had 3 buttons, and nobody wanted 3 buttons on the Lisa mouse or the Apple mouse, but there was a strong camp for 1 button, and there was a strong camp for 2 buttons. Larry and Steve wanted 1 button, so you can be pretty sure the way it turned out. I was actually an advocate of 2 buttons. I don't even remember why. I think because I just wanted that extra functionality, and I wasn't quite as convinced that the press and drag metaphor was going to be easy enough to use, which is basically the way you get around not having more buttons. But I think the interesting thing to take away from that drama is not that the Apple mouse ended up with 1 button and 1 button was right, but to use another quote from Bill Atkinson, when we were designing the Lisa, having these fevered conversations about things like this, he would raise his hand periodically and he would say, we're arguing about diamonds and rubies here, and everybody else in the industry is selling coal. And I think this is a perfect example of that, in the sense that there's very few design decisions where if you wait long enough, you can see both options explored at market scale. But this is one of them. So to this day, an Apple mouse has 1 button, but everybody else's mouse has 2 buttons. All the mice that run on Windows machines and other machines pretty much have at least 2 buttons.
Right.
And you know what? It's all fine. People that have the 1-button mouse, they love their 1-button mouse. People that have the 2-button mouse, they love their 2-button mouse. So we were arguing over whether we were going to have a 1-button diamond or a 2-button ruby. And in the end, it didn't matter. The Lisa and the Macintosh would have been equally successful with either of those design choices. And so I think it's important to remember that from time to time, that sometimes in your passion for whatever perspective you're advocating, you may be passionate about something that's just not as important as you think it is.
Right, yeah. And I guess the trick is figuring out when you're in that sort of situation versus when you're in a situation where...
Exactly. So
you know, it's
The-
diamond versus coal or something.
well, like mouse versus soft keys, I think is not a diamond versus ruby choice, or bitmap display versus character generated display. That was not a diamond and ruby kind of trade-off.
Right.
Anyway,
Well, thank
I don't know
you.
whether you can slip that in somewhere. But
We will put it in just where it landed.
Okay.
Yeah, yeah. Well, thanks again.
you bet.
Thank
My
you so
pleasure.
much.